Welcome to the community session on pathways to disaster resilient infrastructure. I am Pushpendra Johari, your host, and along with me is Rimjim Agarwal, who is the session manager. This show is being organized by RMSI, which is a geospatial analytics firm engaged in disaster risk reduction activities across the globe, helping the governments reduce the risk from natural calamities and man-made calamities to buildings and infrastructure. So let's start the session with a small background as to what the session is going to be covering, so that you have an understanding of what to expect from the session. So while infrastructure is very important for both rural and urban areas, but of late we have seen that there has been migration of, in fact, a lot of migration of people from the rural to the urban areas, to the extent that the projections say that by 2050, nearly most of the world will be living in the urban areas. And we all have seen historically that settlements come first and the infrastructure follows the settlements. So in that scenario, the development of the infrastructure is anyway done in a constrained environment because of the settlements already being there. That induces several performance issues on the infrastructure. Now, these issues get exacerbated because of the additional impacts of the natural and climatic events. But in reality, durability and dependability should be the hallmark of the infrastructure. If the infrastructure goes down, it's not just the investment needed to bring it up online, but there is a lot of indirect impact that is associated with the infrastructure. So today, next slide. Yeah. So today we have a distinguished panel which is going to be discussing and will try to arrive at pathways for laying down an actionable framework for climate and disaster resilient infrastructure development. I will take you to a little bit more deep down assessment of why is it important to have our infrastructure disaster resilient. And then we will talk to Dr. Sushil Gupta and Ms. Alpa Sheth about the vulnerability aspects of the infrastructure. And finally, we will get into the crux of this session, where we will discuss the pathways to disaster resilient infrastructure with our panelists, Dr. Ali Maher from CIT, Mr. Sandeep Pondrik from CDRI, and Mr. Jeffrey Uwema from Info Planning Group. So let's just start with the initial assessment in terms of why it's so important to have our infrastructure disaster resilient. Next slide. So we all understand that infrastructure is the lifeline of our socio-economic development. Whatever we are production that we are creating, whatever the movement of goods to the market, our ability to export, and finally, the quality of life, all these parameters are riding on top of the infrastructure. Next slide. But we have seen that infrastructure has been getting impacted every time there have been disasters. So a few cases in example here are, for example, Hurricane Maria in Puerto Rico. It took about a year to restore power. Cyclone Sidr, Bangladesh, impacted about 75 million people, suddenly lost access to power. Hurricane Wilma, Florida, the grid restoration took 16,000 workers working for weeks at a cost of 1.3 billion. So we can see what is the kind of impact in terms of the direct losses that accrue because of the infrastructure going offline. So next slide. So, but direct impact losses are not the only thing. The indirect losses, they surpass the direct losses when it comes to infrastructure, because we lose our supply chains, we lose connectivity. Both of these result in strong business disruption, and there is an additional impact in terms of increase in shelter and food needs, because even though the houses may or may not have been damaged, but if the important utilities like potable water or electric power are missing, then we need to move them to shelter, because it may or may not be possible for people to live without both these. So just to take a case and example, what if we lose power? There is a complete chain reaction that happens back to back. So it's not just that we lose light, we lose our ability to refrigerate anything. So that because of that, the food storage is at risk. Because of that, the medical supplies which are at risk. We lose our ability to purify water, because the air purifiers and water purifiers all are running on electricity. And then transportation, the entire rail network in most of the countries across the globe is right now riding on the electric powered engines. So in reality, think about it. If just one infrastructure element causes such a delay, such a chaos, then what will happen if more than one get impacted? Next slide. We lost your screen. Yeah. Okay. So what can we do to reduce this risk or to address this risk? Next slide. The first and the foremost thing is we need to understand what the risk really is. For that, we need to start at the hazard. We need to understand what could be the potential hazard intensities at different locations. Then we need to understand where our infrastructure elements really are, and what are their key characteristics. Combining the hazard and this exposure, we can get an assessment of vulnerability by seeing how the infrastructure element might behave to the kind of intensity that it is subjected to because of a specific hazard happening. And that basically positions us for getting an understanding of what the risk could be. Next slide. Once we have an understanding of risk, we can move towards resilience. The resilience could be at the origin or the source, but this may not be possible for every kind of hazard. For example, flood. We cannot control how much rainfall is going to happen. We may be able to put some retaining structures to avoid landslides. So for that, we need to have limiting approaches that limit propagation or the spread, wherein we can use check dams or levees or flood retention ponds, etc. But we still have hazards like earthquake and cyclone, where we can't even limit the propagation. So that the approaches then left for us are to retrofit our existing structures so that their performance in terms of those events improves, or any new structure that we are building has to be built at least to the code, or if not better than the code, depending upon what is the kind of structure that we are trying to build. Next slide. But this risk to resilience process is not very straightforward. There are lots of challenges and gaps associated to that. The first and the foremost thing is that we don't really know where all our infrastructure elements are. They are pinpointed locations on the surface of Earth, along with all the important characteristics. And that leads to risk assessments which are not really very accurate in terms of giving us an idea of what might really happen. Similarly, the focus on the vulnerability assessment so far has been more on buildings, because we were trying to save lives. So the focus was on residential structures, schools, hospitals. So infrastructure from a vulnerability perspective has kind of lagged behind a little bit. So, but it is also complicated because it's not just the function of the structure, but also a function of how well it has been maintained. One of the reasons for probably why infrastructure vulnerability is lagging behind is the unavailability of the historical loss data for the of infrastructure because of various events that have happened in the past. So all these things are basically directing us that the infrastructure risk is very important, but it's not an easy path to follow. There are lots of gaps that we need to fill, and there are lots of challenges. So we move forward discussion with our panelists to understand what their thoughts are about these gaps and challenges, and what their suggestions are for filling them. Next slide. So let's move to our first panel, where we will be talking to Dr. Sushil Gupta as well as Ms. Alpa Sheth regarding the vulnerability of infrastructure elements. Dr. Sushil, we'll start with Dr. Sushil Gupta. Sushil is a disaster risk management specialist, and he is also my colleague. So prior to joining RMSI, he worked for several years at Nuclear Power Corporation of India. He is a seasoned vulnerability expert and has conducted the vulnerability assessments of buildings and infrastructures across the globe. So let's hear from Sushil about the key challenges to vulnerability assessment of infrastructure elements. Sushil.
Thank you, Pushpendra. Rimjim, next slide, please. Okay, when we say vulnerability, so vulnerability we can define as degree of susceptibility and resilience of the community and environment to hazards. Vulnerability could be different type. It could be social vulnerability, where it impacts like livelihood. It could be environmental vulnerability. It could be economic, or it could be physical vulnerability. So here my focus is on physical vulnerability. We will be talking of physical vulnerability of infrastructure. Physical vulnerability can be defined as the potential for physical impact on built environment. So when we say built environment, building and infrastructure and population. It can be analyzed per group of constructions. For example, when we say structural type, which are having similar damage performances. Next. Vulnerability modeling. Usually it is done using vulnerability indices, discrete vulnerability and continuous vulnerability curves. When I say indices are mostly used for social vulnerability or environmental vulnerability, where we don't consider the relationship between hazard and with the hazard intensity with the damage. If I go on the physical vulnerability for infrastructure or for important structures, we go with the development of the damage functions or vulnerability functions. So vulnerability functions can be developed using analytical or engineering studies. We can use if it is available, historical loss data, that is also useful, or third approach is expert judgment or heuristic approach. These could be also like validated or improved through combination of these three. Next. Let me take example of cyclone Fani in India. This was a category 4 tropical cyclone, and this was the biggest cyclone after the Odisha super cyclone of 1999 and 2014 cyclone Fani. It impacted almost 89 fatalities, and total loss was more than $8 billion in dollar. The total power infrastructure damage alone, if I see only the power infrastructure, it was more than USD 1.2 billion. It impacted 5 districts of Odisha state alone, and another 9 districts were extensively damaged. About 4 million people across the state were without power, almost for 40 days. So if you see the infrastructure damage just for the power sector to transmission line and towers of 33 kV, it was of the order of 82%, 11 kV, it was 73%, and substations were 53% were down, and 415 kV distribution lines and towers were about 46%. Next. If you see the photographs before and after. You can see on the top right, the electric tower. You can see it has gone to the water. Same way on the communication towers, you can see that damage was quite extensive. Next. What are the vulnerability factors? So first factor that comes to my mind is design of this infrastructure. This infrastructure has been designed like over a period of time. So where we used old code and guides. So that's the first thing that is a weakest vulnerability factor. Second is material of construction. With the age, material also get weakened. Aging infrastructure, maintenance issues, then corrosion because of saline water. Whole state is along the sea, so there is a lot of saline water. Then damage to foundation, such as from the waterlogging. Next. What are the challenges? Challenges are large network size, component level understanding of structural and non-structural attributes is a big task. And then asset management, maintenance, periodic inspection and condition monitoring, as well as redundancy. Build the redundancy in the network so that we can do, if a like one substation fail, we can island that only that portion, and rest can be like on the power. Next. I think, thank you, and we can have some discussions.
So, thanks a lot, Sushil, for setting the stage for vulnerability assessment, and and getting us an idea into a peek into the risks to power infrastructure. So, basis your experience and your understanding on the subject, what can be done to improve the performance of power infrastructure then?
Thank you. That's an excellent question, Pushpen. In fact, as I said, exposure development, developing this entire network, uh, exposure development of this entire network in a digital way, like in geospatial analysis, and collecting their attribute of each and every network element. So that should be the first task. Second task should be and this not only to the like power transmission line and tower, but from generation itself, because when we say generation, power stations are of different type. For example, nuclear power plant, their vulnerability are different. Solar power plant, their vulnerability is from wind is very high. Then we have a thermal plant, which could be gas fired or coal fired. Then we have wind turbines, which are like most affected from the wind itself. So from generation to transmission to distribution, entire network has to be digitized. Entire network exposure has to be collected. And when I say exposure, it is not just only the location, but attribute. What are the material, what are the design code which has gone into it. Then next comes the vulnerability. Of course, vulnerability through this design code and their condition monitoring, asset management, we can get all those factors where these are weak. And then we can do a risk assessment, because we need to quantify. So everything needs to be quantified. So when after getting the risk assessment, we can do a cost benefit analysis to rank, okay, which part of the infrastructure we should fix first. So that's very important, because resources are limited. So how make a best use of that? Yeah.
Thanks a lot for this, for your insights, and I hope this answer will help a lot of people who are listeners are. So next, we'll move to Ms. Alpa Chet. Alpa is one of the leading structural experts in India, and she has been part of several structural risk reduction initiatives, and she has been a force behind the design of building codes in India. And she herself has designed numerous complex structures. So welcome, Alpa, and we look forward to your insights on the bridges in India. Bridges are complex structures and are very important from a transportation perspective. So we would like to understand from you what is the state of bridges in India, and what are some of the shortcomings that basically makes our bridges vulnerable.
Thank you, Pushpendra, for a very generous introduction. And welcome, good morning, good afternoon, good evening to everybody out there. So Sheila's already painted a broad brush picture of the vulnerabilities. So without further ado, let me move from the general to the specific. And as Pushpendra has said, I'm going to focus on a particular area of vulnerability in our infrastructure, that is bridges. Next slide. Let's see it. Next slide, please. Let's see it through the prism of three parameters: data, asset management, and redundancy. For a country with one of the finest information technology industries in the world, we can surely do better with the quality of our data, its collection and cataloging, its authenticity, the review protocol, and its accessibility. Next slide. Let me share the story of bridge data in India versus elsewhere in the world. Say the US of A. Every 4 years, the American Society of Structural Engineers produces a report card for America's infrastructure that rates the condition and performance of American infrastructure, assigning letter grades based on the physical condition and needed investments for improvement. The committee assesses all relevant data and reports, consults with technical and industry experts, and assigns these grades. It has certain criteria it uses, such as capacity, condition, future need, operation and maintenance, public safety, resilience, and so on. In India, back in 1996, the Roads Ministry commissioned a study for a bridge management system. Software was procured. The system, essentially a database software to be operated by engineers who had to be hired and trained, would assemble data based on numerous parameters. But the system failed. Why? Because the key piece was missing: trained engineers. Also missing was a department who took ownership of the project. Cut to 20 years later. The Indian Bridge Management System, or IBMS, was initiated by the Ministry of Road Transport and Highways with great fanfare and large fund allocation in December 2016. The objective was to create an inventory of all bridges in the country and rate the structural condition for further action. Data collection and sharing of it was subcontracted to private consultants with no standard operating procedures, no competency or qualification criteria for the data collectors, no training to the inspectors, and no peer review of the collected data. The Ministry of the MORT, or Ministry of Road Transport and Highways, claims it has inventorized 172,500 odd bridges, including culverts, under this IBMS. But there is really no qualitative, credible information on the state of bridges. No government agency is taking ownership of the data. There is no sign-off of the data by a government official. And the IBMS project was commissioned for a 3-year time frame. So by December 2019, all the field consultants' contracts were closed on an as-is, where-is basis, and no further steps have been taken to continue with this initiative. So basically, history repeats itself 2 decades on. Even this poor database showed that 20% of bridges are in extremely bad state. Next slide, asset management. Asset management goes hand in hand with a good database. A thorough bridge inspection program helps to ensure small problems never become large ones. A team of bridge inspectors from the public and private sector, qualified on all relevant competence criteria, need to be trained to examine every component of a bridge to determine its physical condition. They need to be skilled in seeking the root causes of the deterioration and the strain which has been caused in the bridge. They need to recommend necessary corrective actions, and they need to evaluate alternative repair rehabilitation methods that meet the specific needs of the bridge and the community. We do need to have this in place. Unfortunately, in the present situation in India, bridge maintenance authorities do not have sufficient budgetary support to undertake large volumes of distress management. The tendency is to develop specifications for cosmetic rectification of visible symptoms rather than to rectify and address the root cause of the defects. This leads to allowing the bridge to deteriorate further till a time when it can be declared critical and recommended for replacement. For example, during the 5 years of implementation of the IBMS, no major rehabilitation program was initiated. Next slide. The last parameter, redundancy, which I'm going to talk about. There are many other parameters, of course. There are many areas in the country where a town or region is connected to mainland through just one bridge or one mountain road. Collapse of that pathway isolates the region. If the area is of significance, multiple paths of access need to be ensured. Alternately, if that is not possible, then the development planning of that region should reflect the inherent vulnerabilities and discourage further growth. We all remember what happened in the case of the Surajbari Bridge, the lone connector of Kutch to the rest of India in the 2001 Bhuj earthquake. The old bridge was already badly deteriorated and experienced horizontal displacement of as much as 1.5 meters. It was therefore not competent to carry any load. The new bridge was also sufficiently damaged. And besides, it was not fully ready. The approach embankments, was still to be constructed. Now, this situation caused huge impediments for rescue and relief in the first crucial week after the quake. Emergency repairs and balance construction were carried out on a war footing to make the new bridge functional. In closing,
can we wrap up quickly?
Yeah, in closing, we know that many of our bridges are in poor condition. We just don't know how bad and exactly how vulnerable they are because the system of knowing does not really exist. Thank you.
All right. Thanks, Alpa, for your insights into the bridges. And a quick question. You know, we are a little behind the schedule. I would just like you to take a few seconds to put your thoughts on what the way forward would be, considering where we are.
So I think, at least for bridges, I would say they can just have, the steps for the short term is just resuscitate the IBMS in a different avatar. In the medium term, I would say they need to train engineers and create a cadre of competent bridge engineers and bridge inspectors. And in the long term, I would say we need to do the prioritization and triaging of the bridges and setting up a criteria for the same, and actually having a plan to retrofit 5% of the compromised bridges annually. It's pretty much the way the US of A does it. Thank you.
Yeah, all right. Thank you very much, Alpa. And this has been a lot of interesting information that you have shared, and very, very relevant and very prudent. Thank you very much. We move forward to our next panel, which is basically getting into the crux of this session, which is the pathways to resilience. We'll start with Dr. Ali Maher, who is a director at the CAIT and a professor of civil and environment engineering at Rutgers. And he has been leading CAIT as a Tier 1 University Transportation Center, is spearheading research through innovative technologies. So, Ali, we would like to understand from you, the situation of the state of infrastructure resilience in US with a specific focus to transportation, because that is your core area. Ali.
Thank you, Pushpendra. Good morning, everyone, and thanks for the invitation to participate in this panel discussion. If I could have my presentation, thank you. Could you please go to the next slide? So what I'm planning to do within this 6-7 minutes is to provide a brief overview on the current state of practice in the US on primarily integrating climate change impacts and resiliency into transportation asset management, which I believe at this time is a timely topic because among other factors, we are now struggling with the impacts of this fierce pandemic. And the picture that is in front of us is basically provides a foretaste of what to expect from cumulative impacts of climate change and how we must essentially prepare to deal with it. What we find here in the transportation sector is we see these similarities between these impacts are striking and closer than what we may think. So that's just a segue here, but important one. So resilience, as you all know, means different things to different people. So where we live, which organizations we represent, and which hazards and assets and sectors we consider, all help define the resilience for us. For example, our colleagues in the earthquake engineering community, they consider resilience an attribute of organizations and consider functional recovery in the shortest amount of time of primary importance in providing resilience. With respect to the transportation sector and assets, the goals are pretty much similar. If you can go to the next slide. The objective here is again to essentially to increase or sharpen the slope of recovery after big events, and that's pretty much the same overview and concept. In the US, next slide please. As with many other countries around the world, I've been hearing your discussions here today, pretty much the same issues. The intensity and frequency of hurricanes, floods, droughts, heat waves, and more intense wildfires are quite alarming. In 2018 and 19, we had about more than $136 billion in monetary damage only, aside from loss of life and other more critical damage. We have had these losses from weather disasters. And this follows 2017, which was the year with the highest damage ever, with 16 weather events and a total damage of 306 billion. That is next slide, please. So as a result of all these events, and even before that, a view is emerging here among our transportation agencies and asset owners and planners and engineers, that when we account for resilience, infrastructure design must include interdependencies, as Pushpendra alluded to a little bit earlier. The cascading effects are critical, and we should consider resilience a function of an ecosystem, essentially, of tightly interconnected and interdependent physical, cyber, and human components. So that adds to the non-linearity and the complexity of the problem in doing vulnerability assessment, doing risk analysis, and ultimately, as Dr. Gupta mentioned, doing benefit cost analysis, which will be critical. So what we are also observing here is that the extreme climate change is posing serious threat to transportation system, interrupting essential services to people, communities, and so on. To provide a point of reference, a summary of US transportation infrastructure inventory is shown in this slide on the left. We have the largest multimodal transportation infrastructure system in the world. It carries more than $10 trillion in goods, roughly about 60% of our GDP. But the challenge here is, how do we maintain a state of good repair of all these assets, while at the same time, we are underspending in doing maintenance and upkeep of these systems. We are only spending about 2.5% of our GDP annually, which, as you can see here, is much less than your country. Next slide, please. In the last 2 years, US DOT, just quickly about some recent developments, it has funded a number of pilot projects across the country and has developed a range of tools and guidance to assess and map climate and extreme vulnerabilities vis-a-vis transportation assets. And they have provided guidance on how to evaluate adaptation options and how to integrate resilience into asset management, which is the key issue here. How do we integrate resiliency considerations into our asset management? Next slide, please. The previous two speakers talked about the vulnerability assessment, and that is part of what Federal Highway Administration in the US and US Department of Transportation did quite a bit of work on and came up with this new guideline. It is called Vulnerability Assessment and Adaptation Framework, which I highly recommend if you don't have access to it, to look at it. It's free for download from internet. It was developed in 2018, and it provides an in-depth structured process for conducting vulnerability assessment, particularly for transportation assets. In addition, a number of tools have and interfaces have been developed in the last 2 years. Please go to the next slide. One tool which is of importance to us that many of the states are beginning to use, and we have been using also on the academic side in helping our industry partners, it's called RAMCAP. It's a methodology that is basically an all-hazard risk and resilience management process for critical infrastructure. So these tools are out there, they are available, but some of the, next slide, some of the research, the current research that my team in our center, we are engaged, and also cuts across various assets, include utilizing advanced data collection methods, to collect multidimensional data sets to produce a coherent view of disaster impacts, utilizing advanced condition assessment, non-destructive testing, structural health monitoring of transportation infrastructure assets. Previously, there was a discussion about bridges, and we have worked on building robotic systems for quick assessment of bridge conditions. You can see a picture here as a part of long-term bridge performance program for the US. So these are areas that are ongoing, research are actively ongoing. The analysis to determine the relationship, for example, between hurricane forces and structural and geographic factors of coastal infrastructure is a priority right now for us. And finally, among other important areas, utilizing artificial intelligence methods such as computer vision and geometric computing methods to extract useful information from large spatial data sets. So I'll stop here, and there are some summaries and takes from what we have learned, some lessons learned, which I would respond during the question and answer period. Thank you. I think I will just wait for the discussions to go over some of these slides.
So thanks a lot, Ali, for the your insights on and enlightening us with the state of affairs with the transportation resilience in US. I am an immediate question that comes to my mind is, with all that is happening, with so many initiatives being taken and under implementation. What is your take on the transportation infrastructure, the way it stands in US today? How will it perform if another big event happens?
Very good question. So I would say two critical developments stand out. The first one is the mandate that the federal government is putting on each state to integrate resiliency into their asset management protocols. And this is actually not being done uniformly. Some states are way ahead than others. And there are folks are working on developing uniform standards and protocols. This work is ongoing. There is, however, a consensus that resiliency needs to be included at all levels of planning, design, and implementation. And the important thing here is that since government is mandating this, means that any project that requires federal dollars, then the planning and execution of the project has to incorporate resiliency into its design, planning, and implementation. The other important item, which again goes back to the challenge of implementing resiliency at local levels, is that, as I go back to Dr. Gupta's presentation, the issue of providing benefit cost analysis, especially we need to show clear evidence, including cost benefit analysis, to convince both the public and politicians that commitment to resilience management is as practical and necessary as any other priority. I think this is a key issue that currently is a common understanding and common, I would say, consensus among asset owners and stakeholders in the US.
Great, thanks a lot, Ali. And in fact, while responding to the previous question, you have already given suggestions as to what those who are jumping onto this area now need to focus on. So great, thanks a lot, Ali, for your thoughts and your suggestions. We now move on to Mr. Pondrik. Mr. Pondrik is the Director General at CDRI, which is the Coalition for Disaster Resilient Infrastructure. He is also advisor for mitigation at the National Disaster Management Authority of India. 1993 IAS officer with over 25 years of experience, and a lot of that has been in heading and managing the infrastructure departments in several states. So welcome, Mr. Pondrik. We would like to, before we start discussion with Mr. Pondrik, we would like to see a short video that shows what the charter of CDRI is. So Rimjim, could you please run the video?
Resilient infrastructure is critical for people's well-being, quality of life, and economic prospects, irrespective of where they live. Inadequate and poorly built infrastructure blocks economic and social development. Increasing exposure to earthquakes, floods, and tropical cyclones stresses infrastructure systems. 2/3 of total economic losses in disasters are associated with infrastructure damage. As extreme weather events become more frequent and intense due to climate change, these losses are set to rise. The impact on small island developing nations and least developed countries is particularly severe. Disaster and climate resilient infrastructure is essential to the achievement of the sustainable development and to accelerate climate action. $94 trillion global investment is needed to fill the infrastructure deficit by 2040. More infrastructure will be built in the next 20 years than in the last 200 years. Fortunately, achieving disaster and climate resilient infrastructure is not expensive. $1 invested in strengthened resilience generates $4 in avoided economic and social losses. The Coalition for Disaster Resilient Infrastructure is an international partnership that will support countries to build the disaster and climate resilient infrastructure they need. Championed by global leaders, CDRI will provide knowledge, technical support, and capacity development to those countries with the greatest infrastructure challenges. Join us to achieve the SDGs and accelerate climate action by making all new infrastructure disaster and climate resilient.
Thanks, Rimjim, for playing the video. Now we move on to Mr. Pondrik, and let's try to understand from him CDRI as a nodal institution for infrastructure resilience. What are the plans? How you plan to bring that change?
So thank you, Pushpendra, and thank you for giving this opportunity to CDRI, and good morning, good afternoon, and good evening to everyone. Let me start by saying that today is the International Day for persons with disability. And in this context, the importance of resilience of infrastructure becomes even more important because we have to make this infrastructure not only resilient, but resilience with inclusiveness for everyone, including people with disability. So with that, I will start the presentation. The Coalition for Disaster Resilient Infrastructure, it was launched last year by Prime Minister of India at the UN Climate Action Summit in New York. It's a multi-stakeholder partnership of countries, organizations, academic institutions, and private sector. The secretariat is based in New Delhi. Next, please. As of now, 18 countries and 4 multilateral organizations have joined the coalition. And if you see the map, almost all continents are represented in the CDRI, from small island countries to countries with more expertise in disaster resilience to landlocked countries. And then we have the major multilateral organizations also have joined the CDRI. Next, please. The CDRI mission is broadly in 3 parts. The first is technical support and capacity building of countries at national as well as subnational level. Research and knowledge management. CDRI will be a knowledge institution, develop and disseminate knowledge, and then advocacy and partnership, as my previous speakers mentioned, that advocacy and partnership is one of the key areas in which we need to work. Next, please. CDRI has started programs and projects in many of the infrastructure areas. And interestingly, what Dr. Sushil Gupta mentioned about the Foni cyclone and the resilience of power sector, CDRI has started a project to assess the resilience of power sector in context of the Foni cyclone. This work has already started, and after it is completed, it will be extrapolated to other similar geographies in the world in member countries. So that work has started in 3 phases, and the first phase is underway. Similarly, CDRI will be working on the airports. Next, please. CDRI will be working on airports also, and we will be conducting risk and resilience assessments. So Dr. Alpa Sheth mentioned about the resilience assessment. So CDRI will be, with coordination and collaboration of member countries, we will be conducting resilience assessments in key infrastructure areas, and some of that work has already started. CDRI will come with a biennial flagship report on the disaster resilience status of the infrastructure in the world. This is a very ambitious project, and the work has started in collaboration with UNDP on this. We expect the first report to be out in 2022. Next, please. CDRI has also started a fellowship program in which fellowships up to US $10,000 will be given to researchers who will work on resilience infrastructure issues, who will do research, and that this fellowship program has been launched in September. The last date is in January, and we are expecting that researchers from all over the world from member countries will apply for these fellowships. Next, please. The International Conference on Disaster Resilient Infrastructure has been scheduled in March. This is the third such event being organized by CDRI. And the major theme of this conference is that we will talk about disaster resilience, including nature-based solutions. And we have already started events in run-up to this conference. Next, please. As I mentioned, that in the three themes CDRI is working, we will be working on recovery and reconstruction, on disaster finance, capacity development, standards is a major area, and governance and policy. Next, please.
Now, Mr. Pondrik, if you could quickly summarize, please. We have one more.
Next, please. Next, please. So yeah, that was it. So I hope CDRI as a multi-stakeholder organization will be able to work on the areas which we are discussing today. That's all from my side. Thank you.
Thank you, Mr. Pondrik. Thank you very much for giving a perspective. And there are lots of hopes you have enlightened by talking about what the CDRI is really planning to achieve. We quickly move on to our last panelist, Mr. Jeff Uwema. Jeff is a planner by profession and as the MD of the Info Planning Group based out of Virgin Islands. So Jeff, quickly, we would like to understand the planner's perspective here. You have been, you have heard the researcher, you have heard the administrator. Now we want to hear what the planner, what is the planner's perspective to all this?
Yes, thanks. Pushpendra, thanks for inviting me to this forum. It's a privilege to be here. Really, listening to the presentations this evening, planning is done, and planners tend to consult experts, tend to look at risk information, tend to develop well-focused plans. But the problem is really operationalizing the plan. So building awareness and understanding is good, but it often doesn't really translate into actions. And so what we've seen in the Caribbean with Irma and Maria that has impacted the Virgin Islands and Puerto Rico is that there was really a quick haste to rebuild infrastructure quickly. So what has happened is that a lot of the planning towards risk reduction was kind of tossed out of the window due to kind of short-term pressures. And the focus was on the asset versus the actual systems and how it functions. So what happens is the asset is restored, but there's still brittleness and there's still a lack of robustness within the system. So the ability of the system to withstand is not there. So, we ask what can be done. And I want to say, well, let's look at the human elements, if you will. And that sounds very simple, but we really need new approaches of thinking about resilience and infrastructure systems, looking at the interdependencies, but also looking at the people that manage and operate the systems and looking at capacity development in a more incremental and long-term approach if we're going to truly build resilience. And so, is there the ability to monitor the systems? Is there a financial capability to maintain the systems? And a big one is there an ability to understand the data that is presented by experts that's part of this panel this evening, to really help make those decisions. So as you do a cost benefit analysis, looking at how to use that information to optimize investments about the assets, but also looking at focusing investments towards the governance systems, and not just in terms of a one-off capacity technical training. I think the shift is really needed to say, look, we're running an infrastructure system. We don't really need the capacity to develop a risk assessment program. What we really need to do is build the capacity to use the data.
Jeff, we'll have to wrap up. We are just closing to our time. So great. Thanks a lot for the planner's perspective, Jeff. And from my side here, we are coming close to this. I hope this session would have been useful to our listeners. And I thank all my panelists for giving their time, especially Jeff and Ali. They are awake late night. Thank you very much. Thank you, Mr. Pondrek. Thanks, Alpa. And thanks a lot, Sushil. And once again, I hope this would have been useful to my listeners. Here, if you have any questions that you would like to send across to our panelists, please send them either to me or to info@rmsi.com. We'll be happy to get you all the answers by discussing with them. Thank you very much for joining us for this community session. And good luck to everybody for the rest of the day. Thank you very much. Bye-bye.